Hello, my name is Leah Evans, and I am an engineer here at ON Semiconductor. Today we are going to address the primary methods used in image stabilization for mobile, consumer, and automotive applications. And we will show you a live demonstration of a robust and efficient image stabilization solution. There are three primary methods currently used for image stabilization for a variety of in-market applications. These are digital image stabilization, or DIS, electronic image stabilization, or EIS, and optical image stabilization, or OIS. The primary concerns in stabilization are the ability to control jitter and blur. Jitter is best described as what happens when your hand shakes when controlling a video camera. It makes the picture shaky and difficult to watch. This is especially apparent when the zoom is fully extended. Blur happens on both still and video cameras when the camera is moved while the camera is capturing an image. To detect the movement and compensate for it while stabilizing the image, various methods are used. The primary difference between DIS and EIS is the method used for motion detection. DIS uses pixel mapping. As you can see in this image, by analyzing the picture, the dog is centered. Pixel mapping realigns the dog via software. EIS uses a gyro to detect the camera motion and compensate for the movement in real time, maximizing pixels and image quality. Both methods compensate for the movement by cropping the image. Because EIS uses a gyro to sense motion, the EIS sensing accuracy is very good. But because it still relies on cropping to compensate for the movement, the image quality is degraded. Here, you can see how the guard band area is used for cropping to compensate for jitter. In most applications, an application processor handles video or signal processing. DIS requires more of the processor's resources to compensate for jitter and movement. In video applications, video compression equates directly to image quality. When cropping is required in methods like DIS and EIS, image quality is degraded through the requirement to constantly downgrade and upgrade the image being captured. In OIS applications, because maximum pixels are used and no downgrading/upgrading is required through the guard band, the compression is maximized and optimized in image quality. Because OIS is compensated internally, it does not need any additional AP resources. In addition, because maximum pixels are captured and used, and no downgrading/upgrading is required through the guard band, the image compression is maximized and optimized in image quality. Exposure is affected by three parameters: aperture or the lens opening, shutter speed, and the image sensor sensitivity for absorbing light. The unique OIS solution offers significantly improved shutter speed that improves exposure compensation by up to 3 stops, well above any of the other methods being used. An OIS solution is typically made up of some main components: an image sensor to determine focal length, a gyro to compensate for movement, and an optical image stabilization. These can be housed in relatively small spaces in one of a couple different standard design layouts. It also typically incorporates either an open or a closed-loop autofocus design. Open-loop autofocus uses a spring to provide tension against the lens and requires a constant draw of power to keep the position against the tension of the lens. By using a closed autofocus system, you don't need a spring and constant draw of power to maintain the lens position for autofocus. The position is known, and therefore there is less power draw to maintain the focus on the application. With the closed-loop system, there is no more relative power draw in macro mode than there is required in the infinity position. This also has a significant effect on the settling time required by each system, because the typical open-loop autofocus takes time to settle and then has to continue to readjust after the fact. Time depends on the algorithm used, but typically the open-loop type autofocus takes quite a bit of time to settle. Closed-loop autofocus systems use the position sensor to determine the lens position, which allows for a faster settling time to complete the focus. As you can see, the settling time is significantly reduced by using the closed-loop method. ON Semiconductor has developed a solution that combines the best of each of these possibilities. It involves an optical image stabilization controller and driver. The LC898-111AXB from ON Semiconductor offers built-in digital signal processing circuits, such as a 2-channel saturation H-bridge, a driver, and a flexible filter circuit, and allows for control of VCM-type actuators. This solution can be further optimized by adding a closed-loop autofocus integrated into the solution, like the LC898122 from ON Semiconductor. In this demonstration, we have mounted an LC898111AXB from ON Semiconductor onto a printed circuit board. The entire board is positioned on a shaker table motor positioned in front of a grid to determine the suppression ratio, which shows visual clarity while the camera is moving. This action simulates someone holding a camera application like a digital still or video camera or a smartphone. Anyone who has taken a picture of video without a tripod knows what the picture of video image looks like without something to compensate for the shaking of one's hand. This demo simulates this activity live. Here you can see what the grid looks like with the shaker table turned on and the optical image stabilization solution turned off. As you can see, there is a high degree of movement in this scenario. Now we will turn on the OIS solution from ON Semiconductor. You can see that the OIS solution greatly smooths the image without compromising image quality. We will now repeat the demonstration by focusing on a photograph to simulate taking a photograph. As you can see with the OIS solution turned off, the image becomes very difficult to see. But with the OIS chip turned on, the increased clarity returns. Thank you for your time. For more information regarding the ON Semiconductor family of optical image stabilization and autofocus solutions, please visit us on the web at www.onsemi.com or contact your local ON Semiconductor sales representative or authorized distribution partner.